Hello, welcome to my multi-part video tutorial series on developing an IoT weather station from scratch. Before I start, I would like to introduce myself. I am Devashish Mahapatra. I have a bachelor's degree in applied electronics and instrumentation engineering, a master's degree in control and automation, and a PhD in electrical engineering. Throughout my career, I have designed many electronic projects, but this one will be my first video tutorial. I hope it will prove useful to some of you, and feel free to give your like or comment if you find it useful. These are the content of the tutorial. I will give a brief idea to what IoT is and what are the components of an IoT system. I will also discuss the typical schematic of an IoT system and show some of the available hardwares you can use to build the IoT-based system. Then I will discuss the MQTT architecture in brief. After the introduction, I will walk you through the step-by-step process of building an IoT weather station, from choosing the hardware through deploying the server and demonstrating the real-time data from the weather station. So first of all, let's see what is Internet of Things or IoT. IoT has two keywords, as you can see, things and internet. IoT consists of allowing things to connect to the existing internet. Now these things are basically microcontrollers or any device, any electronic device that is able to gather information about any parameter and communicate over internet. Now IoT allows the generation of information and it allows the interaction of virtual world with the physical world. Here the virtual world is what you can see on your tablet or PC or smartphone, and the physical world that we live in. A formal definition of IoT can be defined as below. The Internet of Things encapsulates a vision of a world in which billions of objects with embedded intelligence, communication means, and sensing and actuation capabilities will connect over IP or Internet Protocol networks. Here is a schematic of an IoT system. On the left side, you can see some sensors connected to the microcontroller. In the middle, you can see the IoT server. On the right side, you can see the end user devices which use the information from the IoT device to do some useful things. In this case, predict the weather. Here is a schematic of an IoT system. On the left side, you can see some sensors. That is a pressure sensor, a BMP280 series pressure sensor made by Bosch, a DST22 humidity sensor, and an air particulate sensor made by Sharp Electronics. The sensors are connected to the Node MCU ESP8266 microcontroller, which is in the middle, as you can see. And in the yellow block, you can see the virtual private server, which is configured as an IoT server. So here we have the IoT server software. So it's called ThingsBoard. However, we can choose the existing IoT service providers such as ThingSpeak or ThingWorks for the same. On the right side, you can see the end user device which uses information from the IoT devices to do some useful things. In this case, to predict the weather. Now choosing the IoT processor. There are many types of programmable devices that can be configured as an IoT processor. If there is a need for some extensive processing of the gathered data before it is transmitted to the IoT server, then one can choose a more powerful single board computer such as Raspberry Pi, BeagleBone Block, or Intel boards such as Intel Galileo and Edison. But in most cases, simple microcontrollers with internet connectivity options are desirable to just gather and transmit the data. In the next slides, I will show you some of the available devices. Here are some of the single board computers. On the left, you can see the Raspberry Pi 4. Then on the bottom, you can see the Asus Tinkerboard, which is very similar to the, or exactly similar interface to the Raspberry Pi 4, but it has a better processor than the Raspberry Pi 4. And all of these platforms need Wi-Fi to connect to the internet. On the right side, you can see the microcontroller the Node MCU ESP8266. It is the cheapest option available out of all these four devices. And on the bottom you can see another single board computer that is same Raspberry Pi, but it has a very minimal form factor and a much less powerful processor, onboard processor. However, as you can see, all these devices, they have some kind of Wi-Fi interface in them, so they need that to connect to the internet. So they can connect to the internet using your Wi-Fi router. The SVCs on the left can connect 2G, 3G or 4G USB modems, as these have these USB inter ports where you can connect your old USB modems if you have to give them internet access. Devices on the right can connect to Wi-Fi network directly using their inbuilt. So here you can see this is the antenna, a cheap antenna, so that is used to get Wi-Fi connection or Wi-Fi signals from your router. Now this is another option for choosing an IoT hardware. Now this particular model is or microcontroller board or development board, you can say. It is made by MediaTek Labs. So this one has this lithium polymer battery connector, so it can you can connect it. It also has a solar charger, a solar panel connector, so it can it has this its own charging circuit, charging and circuit for to charge this battery, and it has this Wi-Fi plus Bluetooth antenna. So on the back here you can see this protected module. So the SoC or the system on chip present in this board has Wi-Fi, GSM and GPS connection. Now the whole system can be made to operate completely remotely, since it has its own power source and it can refill or recharge its power source in the field itself. So if you are planning to build an IoT system for a very remote area, so this type of system you need to choose, or this type of hardware you need to gather. Either you can get it prefabricated or pre-designed, or you can add the different components accordingly to your microcontroller. Now here we can see our very popular Arduino platform. So you can use this for any IoT devices as well, but bear in mind this does not have any integrated Wi-Fi or any kind of internet connectivity. So for that you have to use it with any other module which provides it the internet connectivity option. On the top left you see the first Arduino board, the Uno, and on the bottom right you see the latest Arduino board that is available right now. And here are more options. Arduino with 4G. As you can see, this module, if you connect it, these are called shields. If you connect this shield on your Arduino, then your Arduino gets 4G. Similarly, there are other modules that provide you other connectivity options such as Wi-Fi or Bluetooth or etc. So choose your microcontrollers accordingly, whichever it is available to you. Here is a summary of the IoT devices introduction part. So basically all IoT devices must talk over the internet. Depending on how they are deployed in the field, one may choose any available option, enabling the IoT device to communicate to the IoT server over the internet successfully. Therefore, if the IoT device is deployed in a remote area, Global System for Mobile Communication, or in short GSM, communication can be chosen. A GSM module can be used with all the IoT devices mentioned above to provide a general packet radio service or GPRS connection. However, advanced or newer modules can also provide 3G or 4G connection to any microcontroller. Moreover, if we are using an SPC or a single board computer such as Raspberry Pi, then we can choose 3G or 4G USB dongles to provide the necessary internet connectivity. In this case, since the IoT device was to be kept just at the outside of the laboratory's window, I decided to use the existing internet connection of the lab, which is available via Wi-Fi. So Raspberry Pi 0 Wi-Fi and ESP8266 integrated Wi-Fi connectivity will do just fine for the future slides. So here we can conclude the part 1 of the tutorial, and in part 2 we will see the different type of sensor connectivities that are available that we can use to build our IoT based system.